In the last video, we discussed embedding, normalization and indexing. In today's video, I will show a small demo using Python. First, we have to set up the virtual environment, then install these required libraries. Here, sentence transform is used to convert text into embeddings. It loads a pre-trained transformer embedding model, converts sentences into dense numerical vectors, ensures semantically similar sentences have similar vectors. FAISS, fast similarity search on vectors. It stores embedding in a vector index, performs efficient similarity search, find nearest vectors to a query vector. In short, FAISS quickly finds similar embedding from large datasets. We will discuss about vector databases like FAISS in the upcoming videos. NumPy. It is used to numerical computations. It handles vector and matrix operations, computes vector norm for normalization, enables fast mathematical operations on embedding. So we need to install these libraries. First, we define a list of documents. These are simple sentences. In real application, these could be a paragraph, PDFs or database records. At this stage, the computer still sees them as a plain text, not numbers. Next, we load an embedding model called all-mini-lm L6v2 from sentence transformers. When we call model.encode, each sentence is converted into a vector of numbers. This process is called embedding. After embedding, every sentence becomes a point in high-dimensional space. Now we normalize the embeddings. Normalization means scaling each vector into unit length. The vector direction stays the same, only the magnitude changes. Next, we create a FAISS index. FAISS is a library designed for fast vector search. We use here index flat IP. IP means inner product. When vectors are normalized, inner product equal to cosine similarity. Then we add all embeddings to the index. This step is called indexing. It helps for fast retrieval, efficient similarity search at scale. Now we take a query. What is RAG? Just like documents, the query is also converted into an embedding. Finally, we search the FAISS index. FAISS compares the query vector with all stored vectors and returns the top k most similar documents. In this example, top k equal to 2. We get the 2 most relevant sentences for the query. Now we can run this script. As you can see, it retrieves the data. So this is a very simple demo to show how embeddings and indexing works. You can try with different data list. I will share the link to the code repo in the description box. So that's all about today's video. Thank you for watching and see you in the next video. Bye.